So number 8 says we want to find the derivative of y is equal to 6 cotangent of 5 theta. We're going to have to use the chain rule here, where our outside function would be the cotangent and our inside function would be the 5 theta. So when we want to find the derivative of y, or y prime, it's going to be 6 times. So the derivative of cotangent is negative cosecant squared 5 theta, but the chain rule tells us we also have to take the derivative of this inside function with respect to theta and multiply it on the outside. So the derivative of 5 theta would be 5. So when we simplify this and clean it up, our final answer would be negative 30 cosecant squared 5 theta. So this problem is very similar to number 8 that we just did, and that we're going to have to use the chain rule as well. This time cosine is going to be our outside function, and then x squared would be our inside function. So the chain rule tells us let's take the derivative of the outside function. So in this case cosine, its derivative is negative sine, and then we leave the inside function as is for now, and then we're going to multiply on the outside the derivative of that inside function. So that'd be 2x, and when we simplify this and clean it up, we get y prime equals negative 2x sine x squared. This problem also asks for the second derivative. So for the second derivative, we're going to have to use the product rule and the chain rule. So to find the second derivative, the derivative of our first part of our first factor, negative 2x, is just negative 2. And we're going to multiply that by the second factor, which is sine x squared. Then plus the derivative of the second factor. So this is where our chain rule comes into effect. The derivative of our outside function would be cosine, and then we're going to have to multiply that by the derivative of this inside function, 2x. But we still also have to multiply by the first factor from our product rule, so times negative 2x. So when we clean this up, our second derivative would be 2 sine x squared minus 4x squared cosine x squared. We can go ahead and put these in parentheses as well to let the reader know that these are the arguments of our trigonometric functions. So for number 19, we're going to have to use the combination of the product rule and the chain rule, where our first factor is e to the 4x and our second factor is sine 6x. So y prime would be the derivative of the first, which is e to the 4x, but the chain rule tells us we have to multiply by the derivative of this 4x times the second factor unchanged, so that would be times 6 sine of 6x, plus derivative of the second factor, in this case that's cosine 6x times 6, because of the chain rule we have to multiply by the derivative of the inside function, times the first factor, so that would be e to the 4x. So when we clean this up, we get 4e to the 4x sine 6x plus 6e to the 4x cosine of 6x. You see that each of these terms has a common factor of 2e to the 4x. This answer is just fine, or you could factor the 2e to the 4x out. But since this problem is asking for the second derivative is easier to take if you leave it unfactored. So let's go ahead and find that second derivative. So y double prime. So the derivative of 4e to the x sine 6x. We actually had taken this derivative already, e to the 4x sine 6x, we just took that and it actually equals this entire result here. So that'd be 4e to the 4x sine 6x plus 6 e to the 4x cosine 6x plus, now we have to take the derivative of the second term. I need a little more space here, so I'll just do it here. Plus 6. So now we actually have to do this work here because it hasn't been done yet. So it'd be e to the 4x times 4 times the cosine of 6x plus negative sine 6x times 6 times e to the 4x. So now we can do a little cleaning up here. That's going to be 16 e to the 4x sine 6x plus 24 e to the 4x cosine of 6x plus 24 e to the 4x cosine of 6x minus 6. 6 times 6 is 36, so 36 e to the 4x sine of 6x. Now we can combine like terms. So the sine 16 minus 36 gives us a negative 20. So negative 20 e to the 4x sine of 6x. And then 24 plus 24 gives us a plus 48 e to the 4x cosine of 6x. And you could factor out 4 e to the 4x if you wanted. So that would leave us with a negative 5 sine of 6x plus 12 cosine of 6x. So 21 is asking us to find the equation of the tangent line to the curve y is equal to sine of sine x at the point 4 pi 0. So the first thing we want to do is find the derivative of y. We're going to use the chain rule here and the rules for differentiating trigonometric functions. So the outside function is sine, the inside function is sine x. So y prime would be the derivative of sine, which is cosine. Inside function doesn't change. Now we have to multiply by the derivative of the inside function with respect to x. So the derivative of sine x would be cosine x. So now to find the equation of the tangent line, we need to find the slope at this point. So to do that, we substitute the given x value into the derivative equation. So y prime of 4 pi is equal to cosine of sine of 4 pi times the cosine of 4 pi. If you remember your unit circle, you have 0, pi over 2, pi, 3 pi over 2, 2 pi. If you keep going, second full revolution, 4 pi would be here. And at this 0, 2 pi, or 4 pi, the x coordinate is 1 and the y coordinate is 0. So the sine would be, the cosine would be 1 and the sine would be 0. So we'll keep that in mind when we get cosine of sine of 4 pi would be 0 times cosine of 4 pi is 1, so this turns to 1. And one more time, the cosine of 0 is also 1, so we're going to have 1 times 1, which gives us 1. So our slope at that point 4 pi 0 would be 1. So we're going to use the point slope equation now. So y minus the y coordinate of the given point is 0 equals, our slope was 1, and then x minus the x coordinate, so 4 pi, would give us y equals x minus 4 pi. So this one is similar to the last problem, number 21, except we're going to use the quotient rule and the chain rule. So we want to find the derivative of y. So y prime would be equal to the derivative of the top, which is 0, times the bottom, 1 plus e to the negative x, minus derivative of the bottom. Derivative of 1 is 0, times derivative of e to the negative x. So be e to the negative x, but then the chain rule tells us we have to multiply by the derivative of this negative x, so that would just be negative 1 times the top, all over the bottom squared, 1 plus e to the negative x squared. Next, we need to do some cleaning up here, so y prime equals, this whole thing goes to 0, minus, that's going to be, well actually plus, because we have a negative times this negative, 2e to the negative x over 1 plus e to the negative x squared. So that leaves us with 2e to the negative x over 1 plus e to the negative x squared. So that is our derivative. So if we want to find the slope of this tangent line at the point 0, 1, we need to substitute this x coordinate into our derivative function. So y prime of 0 would be 2e to the 0 over 1 plus e to the 0 squared. E to the 0 is 1, so we have 2 times 1 over 1 plus 1 squared, which gives us 2 over 4, or 1 half. So now using the point slope equation, y minus 1 equals 1 half times x minus 0. Then we get y minus 1 equals 1 half x, or y equals 1 half x plus 1.